Okay, we made it. Thank God. Hi. Can you hear me? Yes, sort of. We made it. Good. Thank God. We're late. Hi. Per usual. Can you hear me? Yes, sort of.
Like I had zero energy to stream today, but I was like, just do something
per usual.
so that you get back. Like I had zero energy to stream today, but I was like, just do something
per usual.
so that you get back. Like I had zero energy to stream today, but I was like, just do something
per usual.
so that you get back. Like I had zero energy to stream today, but I was like, just do something
per usual.
so that you get back. Like I had zero energy to stream, but still was like, just do something
per usual.
so that you get back. Like I had zero energy.
Are we better? Are we? I think there's still some audio related issues, but no, I think I don't think it should be that bad, because maybe you will hear the AC like that. That should be as worse as it is. But thanks for telling me. It was one of the dashboard thingy monitor stream manager stuff was audio was on, I think. No, that I wouldn't approve of infinite CL talking still. Okay. Here's a tidbit. I mean, I have nieces and nephews, and there have been times when two of them want to talk to me directly, and instead of saying, "Oh, be quiet, let me hear one of you," I'm like, "Okay, let me see if I can understand both of them at the same time." I have tried. I wouldn't say I have succeeded, but I have tried to train myself to listen to two people at once, and it's really funny. But infinite is a bit much for me, even. So, like I said, I am not feeling it today at all. Can we make this like a fun something? Like here's the let's make it a fun thing for me. Like, I really don't want to waste your time, so whoever is here, you do not have to be here. Like, I say 50% of the time I'm doing this stream for myself, and 50% of the time is like, it's cool because you assume that someone might be out there benefiting from it or expecting it, and that is a motivator. But the reason that I'm doing this is mostly for myself. So if maybe, oh my God, are you reading my mind? I was like, I have the video opened, but I was not sure which one I should watch. I was like, I just want to consume something instead of try to solve something. Yeah, I have the one that I have. Let's see. Can we see the screen? Is the one I have is we have a GPT one. There are multiple videos. Let me see. Yeah, see GPT-2. That one's the newest one. This one is the year-old one. Oh, hi. Can we have the mind reading tutorial first? That won't be for me though. Sahil, that is not for me. Wow. Coffee, this is your cue to start streaming about mind reading. Hi Sahil, what's up? How are you doing? So do we just jump to the new one, or would he be like, you should go back to the first one? Has anyone watched any of them? Because like, as you can tell, I tried to go halfway, and yeah, that's like from like maybe a month back. Hello, greetings. Yes. So what do we think? I think it should be safe for me to watch the new one. Let's try. Don't jump. Uh-oh. Thank you. See? Thank you. That was less mind reading and just usefulness. So please, more mind reading and less usefulness. Okay. Let me see if yep, I've only sped it up by 25. I don't think that's a lot. The video is, only 2 hours. That's nothing. Okay. It's more like training. Okay, the other one is more like 100 million parameter, GP2. It's more like fine tuning. The old one is more on how it works. Thank you, I appreciate that. All right. Because it says from scratch, and it's talking about attention is all you need. Good. Is there subtitles? No, they're auto-generated. Cool. No, like in a day on 8 GPUs. Like yeah, like making it with your own hands, basically. All right. Optimize it. The other one is more optimization focused. Got it. I am thinking, let's see, because I really want this to be zoomed in. I'm thinking we go, hold up, here, not there, here. We go here. Oh my god, what did I do? What did I do? Okay. This is a we. Do we go here so that we don't block him? We are still blocking him. Oh well. Okay, fine, I'll use the other one. It's just, maybe it might be small, that's why it's a bit annoying. Can I make the screen a bit bigger? We go there. This is supposed to be because of chat though. Mac screen. There we go. Go bigger. Okay, now we're like friends. And good. I think that's better, right? We can see him. And I can still go to the side all the way to be more nice. Okay, I think that's pretty good. Cool. Starting in 5, 4.
Hi everyone.
Started.
So by now you have probably heard of ChatGPT. It has taken the world and the AI community by storm.
Okay, it's a bit fast. Okay, I'll be nice.
And it is a system that allows you to interact with an AI and give it text-based tasks. So for example, we can ask ChatGPT to write us a small haiku about how important it is that people understand AI, and then they can use it to improve the world and make it more prosperous. So when we run this, AI knowledge brings prosperity for all to see, embrace its power. Okay, not bad. And so you could see that ChatGPT went from left to right and generated all these words sort of sequentially. Now, I asked it already the exact same prompt a little bit earlier, and it generated a slightly different outcome. AI's power to grow, ignorance holds us back, learn, prosperity waits. So pretty good in both cases.
That is, let's see. Oh. So let me see. As far as I know, they do not shut down. They shut down home internets and not work. Like if you are like, I've been at 2 different jobs because it happens every year. they don't shut down workplaces. As far as I know, yeah, like phone devices, like what are they called? Phone plans also shut down. Normal people stuff to avoid cheating, but not work stuff. Sadly, maybe sadly, I don't know. It's fine though. Like, you get used to it. Maybe it starts back on at 8 a.m. So most people don't even feel it. Maybe.
And slightly different. So you can see that ChatGPT is a probabilistic system, and for any one prompt, it can give us multiple answers, sort of replying to it. Now, this is just one example of a prompt. People have come up with many, many examples, and there are entire websites that index interactions with ChatGPT. And so many of them are quite humorous. Explain HTML to me like I'm a dog. Write release notes for Chess 2. Write a note about Elon Musk buying a Twitter, and so on. So as an example, please write a breaking news article about a leaf falling from a tree.
I guess, I don't know. Like, are people in your country feeling more in control? Or, because, like, are they grasping for control? If not, then you're good. I know that in South Korea, they do not allow planes to fly on the exam day. Yeah. CSAT, is that what it's called? I think even it's like no movement for cars, even that. Like, but the annoying thing is, I don't know, like, because it's different from my country. Like, if you have 7 subjects, you do 7-8 exams. Okay, but the one for like SAT style is like everything in one day. I couldn't do that. That's too much for me. That's that way in South Korea. I don't know if it's the same for your country, but like each subject, its own exam. That feels better, and not everything together, because I don't have the brain capacity for that.
In a shocking turn of events, a leaf has fallen from a tree in the local park.
No.
Witnesses report that the leaf, which was previously attached to a branch of a tree, detached itself and fell to the ground. Very dramatic. So you can see that
Have they talked to the family of the fallen leaf?
this is a pretty remarkable system, and it is what we call a language model, because it models the sequence of words or characters or tokens more generally, and it knows how sort of words follow each other in English language. And so from its perspective, what it is doing is it is completing the sequence. So I give it the start of a sequence, and it completes the sequence with the outcome. And so it's a language model in that sense. Now, I would like to focus on the under the hood components of what makes ChatGPT work. So what is the neural network under the hood that models the sequence of these words? And that comes from this paper called Attention is All You Need. In 2017, a landmark paper in AI that produced and proposed the transformer architecture. So GPT is short for generatively pre-trained transformer. So transformer is the neural net that actually does all the heavy lifting under the hood. It comes from this paper in 2017. Now, if you read this paper, this reads like a pretty random machine translation paper, and that's because I think the authors didn't fully anticipate the impact that the transformer would have on the field. And this architecture that they produced in the context of machine translation, in their case, actually ended up taking over...
This will be hung? Yeah, not hanged, hung on museums one day.
The rest of AI in the next 5 years after. And so this architecture with minor changes was copy-pasted into a huge amount of applications in AI in more recent years. And that includes at the core of ChatGPT. Now, we are not going to, what I'd like to do now is I'd like to build out something like ChatGPT, but we're not going to be able to, of course, reproduce ChatGPT. This is a very serious production grade system. It is trained on a good chunk of internet, and then there's a lot of pre-training and fine-tuning stages to it, and so it's very complicated. What I'd like to focus on is just to train a transformer-based language model. And in our case, it's going to be a character-level language model. I still think that is very educational with respect to how these systems work.
Okay.
So I don't want to...
So character-based is supposed to be not like subword or word, right? That's a difference.
Train on a chunk of internet, we need a smaller dataset. In this case, I propose that we work with my favorite toy dataset. It's called Tiny Shakespeare.
Tokenization.
And what it is basically, it's a concatenation of all of the works of Shakespeare, in my understanding. And so this is all of Shakespeare in a single file. This file is about 1 megabyte. And it's just all of Shakespeare.
How are they separated?
And what we are going to do now is we're going to basically model how these characters follow each other. So for example, given a chunk of these characters, like this, given some context of characters in the past, the transformer neural network will look at the characters that I've highlighted and is going to predict that G is likely to come next in the sequence. And it's going to do that because we're going to train that transformer on Shakespeare. And it's just going to try to produce character sequences that look like this. And in that process, it's going to model all the patterns inside this data. So once we've trained the system, I'd just like to give you a preview, we can generate infinite Shakespeare. And of course, it's a...
So it's just like character, even if they're from different, like maybe one of them is Romeo. And this one's Richard, King Richard, I'm guessing. Cool. Well, no titles, just work.
fake thing that looks kind of like Shakespeare.
This is so pretty. I mean,
apologies for there's some jank that I'm not able to resolve in here, but
it makes good art though. It makes me remember like those paint like apps we would use as a kid, and you just created like multiple crayon like cursors, and then you would just draw all over, and it would create some, what is it called? I forgot. Anyway.
You can see how this is going character by character, and it's kind of like predicting Shakespeare-like language. So, verily, my lord, the sights have left thee again, the king, coming with my curses with precious pale.
Sure.
And then Tranio says something else, etc. And this is just coming out of the transformer in a very similar manner as it would come out in ChatGPT. In our case, character by character. In ChatGPT, it's coming out on a token by token level, and tokens are these sort of like little subword pieces. So they're not word level, they're kind of like word chunk level. And now I've already written this entire code to train these transformers, and it is in a GitHub repository that you can find, and it's called NanoGPT. So NanoGPT is a repository that you can find on my GitHub, and it's a repository for training transformers.
Kaleidoscope? Ooh, what is L system? Sure. You know what? Because it's a lazy day. It was called Child's Play, the app I was using. Child's Play. And then should I say app? Would anything come up? I wouldn't call it a video game. It was not a video game. It was a paint-like. Oh, wait, is that it? I don't think so. But that was not. I don't think this was it. It wasn't creepy. This is creepy. Educational game? Not really. Why can't I find it? Child's Play. It would be like, this is Child's Play, and then you would. I can't find it. If I write this is Child's Play, it won't come up though. Oh, hi Jay says, today is a lazy stream day, so there was a 80s horror movie. You mean Chucky? Is it also called Child's Play? Hold up. 88 should be that one, right? I'm gonna say paint. I mean, what else do I call it if not app? It was an app. Oh my god, this is it? Is that it? No way. This is a new version. This makes me feel like it was. But these are all iPad versions. No. Kid Paint app. I think that's, yeah. But like, it was old. Are there any videos? See, there we go. This is it. Oh, why is it Korean? I better hear that this is Child's Play. Ya Allah. Oh my god. Yeah, was called Child's Play. Maybe. What's happening?
This is Child's Play.
There you go. That's how I learned English. I'm kidding. There's no way. Oh, when you pressed undo, it would be like, uh-oh. I'm going back to my childhood. Wow, art. See, this one. You see it? This feature up here? I don't know if you can see it. I'm gonna zoom in to when he presses it, or she. I don't know. Is that it? Did we get there? Okay, yep. Uh-huh. The rainbow thing. Oh, wait, you moved on from pen. The bubbles. Hold up. That's what it was called, Child's Play. And I used to play as a child. Is that it? Are we there yet? We're still not there yet. No. Oh my. This is how you could clean the screen. How fun is that? You would bomb it. Yeah, no, this is where transition? Oh, cut. Look. This is cut, copy, paste. Art. We're still not there yet. There we go. We are getting there. Deluxe paint. See? This here? It becomes 4 different pens. 4 different parts of the screen. Oh my god, I love this one. What was that? I forget this one though. What was that? Was it cleaning? I think it was just not an eraser. Isn't this fun? How fun? There were fish sounds. I'm sure about this one. Look, this is 3D. This is 96. I'll stop. What is this one? What? Wow. Oh, you could make it. Yeah. See, scramble. You could scramble it. Like, what happened? Come on. See? Scramble it. What fun is this? Super Hit Pics, Super 90s style. I'm gonna send this to someone later. So that they feel nostalgic as well. Pics. Oh no, wait, Kid Pics. What's happening to me? Kid Pics. Oh, that is also very 90s. I love this style of look how creative we were. Wow. So there was a 3D version and a 2D version. I still prefer Child's Play. As if being nostalgic, makes stuff better. It always does. So, someday people will be nostalgic to ChatGPT. Just you wait. I'll send it in a bit. I just want to paste the link because our dearest Mac doesn't have a, what is it called? The thing that history in pasting. Windows does. Okay. What happened to good old ASCII art? Do you remember when we used to draw on the wall of caves? Good old days. Was like a late 80s, early 90s professional version. Ooh, Just calling it deluxe makes it less child version. So let's try deluxe paint. Did I get there? Of course. What? Oh, there it is. Ooh, is that a pharaoh? Should I flex my accent and say when saying pharaoh we say Faraon? Ooh, retrospective, as in like talking about it, not just using it. This is really fancy. Can you make 3D stuff? This is really cool. Like half of these are album art style stuff. Whoa. I still don't think this is 3D. It's just really well shaded. This is beautiful. Nice. No way. This is 3D now. No, still very well shaded. I don't know. Human brains. Cool. Yes. Rabbit holes. Let's get out of the rabbit hole. Oh, what opened this rabbit hole? Hold up. What opened this rabbit hole? Good question. When did I first see this thing and it made me think of it? I don't think it was during this video. No, definitely not during this video. Wait, how did you open this rabbit hole? I can't be sure. I just saw something and it reminded me. Oh, shoot. Yeah, I remember. Okay. 549. If I go back, he's running this, and
of course it's a fake thing that looks
the
kind
output,
of like
see,
Shakespeare.
Looks like this. And I thought it reminded me of this.
Apologies for, there's some jank that I'm not able to resolve in here, but
it reminded me of this pen all over, the screen thing. Yeah. Okay. I have a short memory, like a fish. The way the text was being outputted on the command window. We're back? Is that how commercials end? Because started with kind of ASCII art. Ironically, yeah. Obviously that's where it should start. Yeah. I don't know. Yeah, I doubt anyone here has watched Space Tune, the Arabic version. I don't know if there's an English version, but when they were back from commercial, they would be udna, which means we're back. So we're back. Commercials are over.
It's in a GitHub repository that you can find, and it's called NanoGPT.
Wait.
Nano in a code, and now
hold up. I need to go back.
And tokens are in ChatGPT. It's coming out on a token by token level.
Yeah.
Tokens are these sort of like little subword pieces. So they're not word level. They're kind of like word chunk level.
Less than words. Got it. Trying to be on the same. Yeah. Back. Okay.
And now I've already written this entire code to train these transformers, and it is in a GitHub repository that you can find, and it's called NanoGPT.
Okay,
so NanoGPT is a repository that you can find on my GitHub.
He's already written it. Good to know.
And it's a repository for training transformers on any given text. And what I think is interesting about it, because there's many ways to train transformers, but this is a very simple implementation. So it's just 2 files of 300 lines of code each. One file defines the GPT model, the transformer, and one file trains it on some given text dataset. And here I'm showing that if you train it on an open web text dataset, which is a fairly large dataset of web pages, then I reproduce the performance of GPT-2. So GPT-2 is an early version of OpenAI's
Comment in both chats,
GPT.
I think, rather than like saying hello to someone in the wrong chat and hoping they see. Oh, okay. Because like I can comment in both chats because I'm using Restream, but I don't want you to. Okay. Sure. It actually doesn't matter for me. I just can see where you're chatting from. However you feel comfortable. Cool. There we go. That's me chatting both sides.
From 2017, if I recall correctly, and I've only so far reproduced the smallest 124 million parameter model, but basically this is just proving that the code base is correctly arranged, and I'm able to load the neural network weights that OpenAI has released later. So you can take a look at the finished code here in NanoGPT, but what I would like to do in this lecture is I would like to basically write this repository from scratch.
Aww.
So we're going to begin with an empty file, and we're going to define a transformer piece by piece.
I think I've said this before, but I'll say it again. When tutorials write with you instead of explain what's already written, there's a level of like care that is given to the person who is learning the tutorial. Because, yeah. No way we need as many GPTs as websites. I knew it. Yeah. I mean, sometimes, I don't know, even if it's coming from a company, the first thing you make is like the chunkiest, and then you can optimize for it. Maybe this is an optimizer, more optimized version. Hi. Okay.
We're going to train it on the tiny Shakespeare dataset, and we'll see how we can then generate infinite Shakespeare. And of course, this can copy.
Can tiny Shakespeare become infinite tiny Shakespeare? I need some art on this. I'm sure it's out there though. If not, some AI is going to make it.
Copy-paste to any arbitrary text dataset that you like. But my goal really here is to just make you understand and appreciate how under the hood ChatGPT works.
Bob's
and,
birthday,
really all that's
Wait, what happened? Just too confident. He seems so relaxed, like with live coding GPT. Yeah, I know. Yeah, remember we said when it comes to live coding, it should be something that you can do in your sleep. He probably sleeps and dreams about Transformers. I'm jealous. Uh-oh. What happened? Why is CL not moving? CL, wake up. Oh, she's up. There we go. I don't get the Bob's birthday GPT. Is that a joke? The only Bob I know is Bob Ross. And there 100% needs to be, I don't know, maybe that actually is disrespectful. If we make a GPT trained on his, oh my god, now, oh no, bad ideas. Now I'm thinking we make voice clone, because his voice is really calm. Because the other day I was trying to use, there we go, now I know why it stopped working. I'm still here. I will try to fix this problem. I might fail at it. I'm gonna do a BRB, I'm sorry. We don't need as many GPTs as Facebook posts. Okay. Definitely. LinkedIn, Facebook, all of that. Okay, I think you can technically still hear me, but now this is a BRB. Oh, whoa. Hold up. What happened? Oh, okay. While I'm here, I can hydrate. Thank you. I should do that. I don't know why AnyDesk keeps bailing on me today. Maybe I'm using a different Wi-Fi. Yeah, I am using 2 different Wi-Fi routers, stuff, whatever. Okay. Hydrating in 5. Okay. Not everything I do is a countdown. Sometimes they're not. Cool. Okay. Yes. Yeah. I don't think there's a person on this planet that's not jealous of Andre Karpathy. I can't say just Andre. Like, it feels weird to just call him Andre. We're not on a first name basis yet.
What's required is a proficiency in Python and some basic understanding of calculus and statistics. And it would help if you also see my previous videos on the same YouTube channel, in particular my Make More series, where I define smaller and simpler neural network language models. So multi-allele perceptrons and so on. It really introduces the language modeling framework. And then here in this video, we're going to focus on the transformer neural network itself.
Okay, got it. Isn't there was a church that started using ChatGPT. There was a thing about that, right? I'm very sure that there was a video about that. I think it was from Moist Critical, right? Is that how you say his name? I don't know. You know who? Yeah.
Okay, so I created a new Google Colab Jupyter notebook here, and this will allow me to later easily share this code that we're going to develop together with you, so you can follow along. So this will be in the video description later. Now, here I've just done some preliminaries. I downloaded the dataset, the Tiny Shakespeare dataset, at this URL, and you can see that it's about a 1 megabyte file. Then here I open the input.txt file and just read in all the text as a string.
Okay. Star Trek villain style, huh? In church, but why villain? Who says the AI has to be villain?
And we see that we are working with 1 million characters roughly.
Like,
and the first one,
even when it comes to there's a story, but all GPT is going all knowledge. Isn't current all knowledge human-made knowledge? How can you escape that?
1,000 characters, if we just print them out, are basically what you would expect. This is the first 1,000 characters of the Tiny Shakespeare dataset, roughly up to here. So far, so good. Next, we're going to take this text. And the text is a sequence of characters in Python. So when I call the set constructor on it, I'm just going to get the set of all the characters that occur in this text. And then I call list on that to create a list of those characters instead of just a set, so that I have an arbitrary ordering. And then I sort that. So basically we get just all the characters that occur in the entire dataset, and they're sorted. Now the number of them is going to be our vocabulary size. These are the possible elements of our sequences. And we see that when I print here the characters, there's 65 of them in total. There's a space character, and then all kinds of special characters.
Where is new line?
Capitals and lowercase letters. So that's our vocabulary, and that's the sort of like...
How come new line is not here? Because of the join? Is new line not a character? Then we're all linked up. Okay. Still, it's just, I guess, yeah, it's all alive human knowledge. And then starting from when we're all linked up to, then when you die, you probably become some sort of hologram or something. Or a brain in a jar.
Like possible characters that the model can see or emit.
Okay.
Okay, so next we would like to develop some strategy to tokenize the input text. Now, when people say tokenize, they mean convert the raw text as a string to some sequence of integers.
Oh, okay. Now if we include parallel worlds and dimensions, then we're not limited by human knowledge. Because I sort of, like, it doesn't make sense for one not to believe there is other things out there in such a big world. So, yeah. Parse line by line, so new line is not seen. Good point, good point.
According to some according to some vocabulary of possible elements. So as an example, here we are going to be building a character level language model. So we're simply going to be translating individual characters into integers. So let me show you
Okay.
a chunk of code that sort of does that for
Somewhat
us.
tokenization.
So we're building both the encoder and the decoder. And let me just talk through what's happening here. When we encode an arbitrary text, like hi there, we're going to receive a list of integers that
My
represents
Adventure is
that
Superman.
string.
I have not. Is it the one where it's supposed to be Superman's? No, not Superman. That one is Batman's kid? Because I haven't seen that one as well. If it's a cute cartoon, it's something I can watch with animated series. Aw. I don't think I have. Is this recent? Very recent. It looks like this frame looks like it's from some 90s cartoon, which I like. It's a positive thing. Cool. I can 100% watch it with my nieces and nephews. Whose Lane is meant to be part Korean. Cool. It is animated. Anime inspired style. It will be all consciousness. Cute. Including all yes, no branching. Ooh. Whoa. All possibilities. How many GPUs would that need? Okay. I think Superman is supposed to be somewhat teaching morals. Somewhat. Because like the most recent thing I was watching with when they come over was series of unfortunate events, which is like the opposite way of teaching morals, but makes the kid learn the morals. But it's like counterintuitive. I like it. Not everyone can watch it at a young age. Or maybe, I don't know. Anyway.
So for example, 46, 47, etc. And then we also have the reverse mapping. So we can take this list and decode it to get back the exact same string. So it's really just like a translation to integers and back for arbitrary string. And for us, it is done on a character level. Now, the way this was achieved is we just iterate over all the characters here and create a lookup table from the character to the integer and vice versa. And then to encode some string, we simply translate all the characters individually, and to decode it back, we use the reverse mapping and concatenate all of it.
Parallel worlds include all of our personal yes, no. Yeah. You're right. What was I thinking of? I was thinking of, I forgot. There's a thing like yeah, okay, difference of view that's made different decisions. That would be parallel worlds. Yeah, you're right. But like every decision, like that's too much.
Now, this is only one of many possible encodings or many possible sort of tokenizers, and it's a very simple one. But there's many other schemas that people have come up with in practice. So for example, Google uses sentence piece. So sentence piece will also encode text into integers, but in a different schema and using a different vocabulary. And sentence piece is a subword sort of tokenizer. And what that means is that you're not encoding entire words, but you're not also encoding individual characters. It's a subword unit level. And that's usually what's adopted in practice.
Uncomputable if infinite lifetimes and infinite choices. Oof. Yeah, there's a world where dinosaurs roam the earth. Anyway, uncomputable because we're thinking to be made by our computers. Like the whole, if we live in a simulation, then why is it uncomputable? So maybe we have to make simulations ourselves. Simulation within simulation. Oh no. Anyway, now I'm thinking Pantheon.
For example, also OpenAI has this library called TickToken that uses a byte pair encoding tokenizer, and that's what GPT uses. And you can also just encode words into, like hello world, into a list of integers. So as an example, I'm using the TickToken library here. I'm getting the encoding for GPT-2, or that was used for GPT-2. Instead of just having 65 possible characters.
Sets of families from our simulation?
Or tokens, they have 50,000 tokens. And so when they encode the exact same string, hi there, we only get a list of 3 integers. But those integers are not between 0 and 64. They are between 0 and 50,256. So basically you can trade off the codebook size and the sequence lengths. So you can have very long sequences of integers with very small vocabularies, or you can have short sequences of integers with very large vocabularies. And so typically people use in practice these subword encodings, but I'd like to keep our tokenizer very simple. So we're using character level tokenizer. And that means that we have very small codebooks. We have very simple encode and decode functions, but we do get very long sequences as a result. But that's the level at which we're going to stick with this lecture because it's the simplest thing. Okay, so now that we have an encoder and a decoder, effectively a tokenizer, we can tokenize.
No, I think we're just thinking about the idea of parallel worlds theoretically. I think we've escaped AI. Different life based on just like what parallel worlds. Is this supposed to be parallel world or universes? Are these different? I don't know. It's a fun brain exercise.
As a result. But that's the level at which we're going to stick with this lecture because it's the simplest thing. Okay, so now that we have an encoder and a decoder, effectively a tokenizer, we can tokenize the entire training set of Shakespeare. So here's a chunk of code that does that. And I'm going to start to use the PyTorch library, and specifically the torch.tensor from the PyTorch library. So we're going to take all of the text in Tiny Shakespeare, encode it, and then wrap it into a torch.tensor to get the data tensor. So here's what the data tensor looks like when I look at just the first 1,000 characters, or the 1,000 elements of it. So we see that we have a massive...
Hold up. We're just using tensors for the fun of it? Okay, we tokenize the entire thing.
Encoder and a decoder, effectively a tokenizer, we can tokenize the entire training set of Shakespeare.
Yes.
So
that's a tradition. Parallel worlds exist in parallel in our universe, or maybe because we're not supposed to see them. Each of us are in our bubbles. Each time I think of that, I reimagine the graphic made by Cosmos, the new version, not the old version. The old version is also pretty fun. I don't know if you've watched it, but it's a really fun TV show. Most neighboring parallel worlds would almost exactly mimic our own. Yeah, it's like we would be in space being only one recent quantum interaction different. Yeah. Like, what do I care if two particular... See? Like, because if it's every choice, then each breathing in and breathing out creates hundreds, right? Also, yeah, I'm thinking like embedding space would be similar. So yeah. They mimic, but the alternative choices exist in... Yeah. Definitely. You'd have to jump a bit further. Just like Spider-Man Part 2. Or Part 1 even. Spider-Verse.
Here's a chunk of code that does that. And I'm going to start to use the PyTorch library, and specifically the torch.tensor from the PyTorch library. So we're going to take all of the text in Tiny Shakespeare, encode it, and then wrap it into a torch.tensor to get the data tensor. So here's what the data tensor looks like when I look at just the first 1,000 characters, or the 1,000 elements of it. So we see that we have a massive sequence of integers, and this sequence of integers here is basically an identical translation of the first 1,000 characters here. So I believe, for example, that 0 is a new line character.
I can't help being on Team Pilot Wave. Wait, what's Pilot Wave? Supposed to form. Yeah, but you don't have to. Answering the last message by JSS. There's also one where you don't. What's Pilot Wave? Is that supposed to be some physics? Oh, it is a theory. There we go. Bohemian, okay, was the first known example of hidden variable theory. Yeah. Somewhat disproven interpretation of quantum physics as an alternative to many worlds, and I don't know what you mean by Copenhagen because it's a place, but Schrodinger's cat is here. It's everywhere. More modern version of this thing as a deterministic theory and avoids from 27. Okay. I will need to watch something on this before I make a informed decision. Higher order number of alternative consequences of each yes/no branch. Not sure I understand your last point, but
and maybe 1 is a space. Not 100% sure. But from now on, the entire data set of text is re-represented as it's just stretched out as a single very large sequence of integers. Let me do one more thing before we move on here. I'd like to separate out our data set into a train and a validation split. So in particular, we're going to take the first 9.
Really, most popular interpretation of quantum physics considered the shut up and calculate. Yeah, I know. I'm not even gonna say I know anything about quantum physics, but it's still like I've heard the term quantum physics. I've watched some PBS. Is it? Wait, what is it? Anyway, each time I watch any of the videos from the PBS, very physics related channel, it all goes over my head, but it's still fun to watch.
90% of the data set and consider that to be the training data for the transformer. And we're going to withhold the last 10% at the end of it to be the validation data.
Okay.
And this will help us understand to what extent our model is overfitting. So we're going to basically hide and keep the validation data on the side because we don't want just a perfect memorization of this exact Shakespeare. We want a neural network that sort of creates Shakespeare-like text. And so it should be fairly likely for it to produce the actual, like, stowed away true Shakespeare text.
Okay.
And so we're going to use this to get a sense of the overfitting. Okay, so now we would like to start plugging.
Thank you. PBS Spacetime, that's the channel with a guy with the cool hair. A day consists of too many. Like, breathing is sometimes a choice. Like, I'm talking, I'm not breathing, but when I stop talking, I'm breathing. Every word that's coming out of my mouth is a choice. Too much. Like, for my brain to compute.
These text sequences or integer sequences into the transformer so that it can train and learn those patterns. Now, the important thing to realize is we're never going to actually feed the entire text into the transformer all at once. That would be computationally very expensive and prohibitive. So when we actually train a transformer on a lot of these data sets, we only work with chunks of the data set. And when we train the transformer, we basically sample random little chunks out of the training set and train on just chunks at a time. And these chunks have basically some kind of a length and some maximum length. Now, the maximum length typically, at least in the code I usually write, is called block size. You can find it under different names like context length or something like that. Let's start with the block size of just 8. And let me look at the first train data characters, the first block size +1 characters. I'll explain why +1 in a second.
No. No, Kyle Hill's hair is not cool. Like it's majestic. it's different. No. PBS Spacetime guy also has cool hair. Or maybe, I don't know if he's changed his style, but last time I watched, he had cool hair. Yeah. Kyle Hill is on a different level, man. Yeah. Oh, yeah. Oh, it's Australian. Yeah. And very deep voice, very full voice, yeah. I swear he has cool hair. Now you're making me. PBS Space Time. Maybe.
Have you ever asked?
He does, look. Like, there.
What is beyond the edge of the universe? And have you ever been told that an infinite universe has no edge?
Yes, No Edge is a song by Hank Green. Cool. Yeah. Cool hair can be different. Anyway. No clock propagation and just using GPUs in parallel. If you're asking for my opinion, I'd say I don't have any information. I don't know what is better. I don't know, which one would be more costly and less costly. Can't be sure.
So this is the first 9 characters in the sequence, in the training set. Now what I'd like to point out is that when you sample a chunk of data like this, so say these 9 characters out of the training set, this actually has multiple examples packed into it. And that's because all of these characters follow each other.
Okay.
And so what this thing is going to say when we plug it into a transformer is we're going to actually simultaneously train it to make prediction at every one of these positions. Now, in a chunk of 9 characters,
you can learn without backpropagation, but okay. Why is there extra space here? Anyway, I shouldn't focus on something that might be trivial, but still.
There's actually 8 individual examples packed in there. So there's the example that in the context of 18, 47 likely comes next. In the context of 18 and 47, 56 comes next. In the context of 18, 47, 56, 57 can come next, and so on. So that's the 8 individual examples. Let me actually spell it out with code. So here's a chunk of code to illustrate. X are the inputs to the transformer. It will just be the first block size character.
This is here to make the numbers line up? Like, oh, I was about to scroll up and down because I thought I'm using this notebook. But like, I see them after every one. Right? Commas have equal spacing. Maybe, I don't know. Just watch the short clip here from Perplexly. Okay. Sure, we can do that. They form nice. Oh, yeah, you're right. They do. Could be that. Could be that. Yeah, remembering is not easy. sometimes.
Characters. Y will be the next block size characters. So it's offset by 1.
Mm-hmm.
And that's because Y are the targets for each position in the input. And then here I'm iterating over all the block size of 8. And the context is always all the characters in X up to T and including T. And the target is always the Tth character, but in the targets array Y. So let me just run this. And basically it spells out what I said in words. These are the 8 examples hidden in a chunk of 9 characters that we sampled from the training set. I want to mention one more thing.
There was a Friedman interview with Perplexly CEO. I've not listened to it. Is Perplexly the Oh yeah, it was shared on stream very recently. It was the one where it would give you good links. Yeah. Okay. Still a chat LLM, but it searches online, I think. Yep. Worth a watch. Yeah, I know. Too much media. I mean, the people he brings, there's a percentage of them that are very interesting, and yeah. I also have I understand. I also get the same feeling, but sometimes the people he brings are very interesting. Yeah. Like, it's not the people's fault that the podcast has a reputation. Yeah. Only watch the ones with Mark. Who's Mark? So easy to follow. Who's Mark? Eat coffee. Okay, you hit your threshold of time. Here? Okay. Learning not to watch AI hype channels. Cool. Each of us. Oh, Mark Zucker. It's like, how many Marks are out there? Because, Mark Cuban, I don't know if he was ever. Maybe he was. I don't know. I think he was. Yeah. Yep. Hi, Ed. What's up? Yeah. Yeah, I think everyone got to know him when he did the when he did the MIT course. And I still think that his opinions are, like, from what I've watched, I don't have a problem with his opinions, but I don't know, maybe he platforms controversial people, which becomes, yeah. Like, I don't know who that is. Wes Roth. Informative, but okay, cool. Yeah, there's a difference between AI hype and, like, saying, I don't know, I'm just, like, giving examples of, like, make $1,000 a day with AI versus ones where they explain stuff. I like the ones where they explain stuff. It's like, I've been watching a lot of videos by a person called ByCloud, YouTube channel, and I liked their one on text to speech because it was very, like, informative to me. Recommendations they will swarm. Yeah, you watch one and then they follow like ducklings. True.
Thing. We train on all the 8 examples here with context between 1 all the way up to context of block size.
So our, I'm gonna call it an engram, is size 8. That's a lot. 1 million in 5 minutes. That's, you've fallen off. Like, it should be 1 million in 1 minute. I think if you watch AI stuff on YouTube, you'd know Wes Roth. Maybe I haven't watched. Maybe I haven't memorized the name, but maybe. I can't be sure. Like I'm currently scrolling. I remember. No, I don't. It was a different thing. But yeah, the thumbnail does seem somewhat. Can't be sure. Yes. And then yeah, anyway.
We train on that not just for computational reasons because we happen to have the sequence already or something like that. It's not just done for efficiency.
But
it's also done to make the transformer network be used to seeing contexts all the way from as little as 1 all the way to block size. And we'd like the transformer to be used to seeing everything in between. And that's going to be used.
Yeah. I mean, it's hard not to avoid the OpenAI drama. Like everyone talked about it. But yeah, more than that, it becomes too much. Slowly learning not to watch them. Yep. You went through the history of them, and then yeah.
Useful later during inference because while we're sampling, we can start the sampling generation with as little as 1 character of context, and the transformer knows how to predict the next character with all the way up to just context of 1. And so then it can predict everything up to block size. And after block size, we have to start truncating because the transformer will never.
Yeah, it was good content for a while. Yeah. You know, they say nothing is more. I don't know what's. Yeah. Anyway, reality is always more shocking than fiction. I think that's what they say.
Receive more than block size.
Oh, hi. I wonder if you shuffle these n-grams across all sentences in your data or not. I don't think you should, because it matters. Context matters, and if you shuffle, it will ruin context. But like, first thing, vocab is created, then the conversion, the encoding, and then when you encode the whole training set, this is just us looking at it. We need to parse all the transcripts. And you can't shuffle because then you will lose context. It's just like looking at characters, but now we're looking at things in context. So like this 47 is supposed to be between those two in this, let's say, word. And yeah. I think the n-gram stuff is just for illustration before training a transformer. Maybe, but we do have block size of 8. So let's see if we do anything with it. I mean, if you have 3 data, what would 3 data mean? Which have 5 context length, do you shuffle across? Was it 15? Sorry, I don't think that illustrated well for me. You will still keep the order. Oh yeah, keeping order matters. After the n-gram thingy for each data. So we have 3 data which have 5 context length. So we have, let's say, 3 rows. Each of them have 5 context length. Do we will put them all together. That is okay. And then we would this here is put all together, like the whole sentence, like paragraph, is like you put them all together, and from what I understand, we no longer have new lines. So it would be like the context is 15 and not 5. Yes. Everything is put together. And depending on your window, you just walk through it. Yeah. I hope I understood your point. And yeah. We talked about tokenization. Yeah. Hi. Sayed? Sharikh or Sharikh? I can't be sure. I mean, I know you've been here before. I just still don't know how to read your name, so I'd appreciate it if you can tell me. I think they overlap. I also agree that they should overlap. If, yeah. See, exactly. Yeah, and it's okay if they overlap and they are put next to each other. Thanks for the illustration. In a better way. I should have also been able to do something like that, but yeah. Wow, I didn't think that I could show it on the screen. Yeah.
But when it's predicting the next character. Okay, so we've looked at the time dimension of the tensors that are going to be feeding into the transformer. There's one more dimension to care about, and that is
even here, I think like this is one part, and then this is the next part of let's say another sentence. So that should be, oh yeah, padding. I think right now, right here, I don't think we're doing padding. I think we just made it one long sequence, and then we chunk them. But yeah, padding is also obviously something that is done.
The batch dimension. And so as we're sampling these chunks of text, we're going to be actually, every time we're going to feed them into a transformer, we're going to have many batches of multiple chunks of text that are all like stacked up in a single tensor. And that's just done for efficiency, just so that we can keep the GPUs busy.
Yeah, so they are very... I think he's explaining it, but I'm going to go back so that we listen to them again. Okay. Okay, so we've looked at the time dimension of the tensors that are going to be feeding into the transformer. There's one more dimension to care about, and that is the batch dimension. And so as we're sampling these chunks of text, we're going to be actually, every time we're going to feed them into a transformer, we're going to have many batches of multiple chunks of text that are all like stacked up in a single tensor. And that's just done for efficiency, just so that we can keep the GPUs busy. Okay. Like rows in a table. Yeah, it reminds you of padding. Because they are very good at parallel processing of data. And so we just want to process multiple chunks all at the same time. But those chunks are processed completely independently. They don't talk to each other and so on. So let me basically just generalize this and introduce a batch dimension. Here's a chunk of code. Let me just run it, and then I'm going to explain what it does. So here, because we're going to start sampling random locations in the dataset to pull chunks from, I am setting the seed so that in the random number generator, so that the numbers I see here are going to be the same numbers you see later if you try to reproduce this. Now the batch size here is how many independent sequences. These mini batches will need to be padded to be the same length. I'm thinking they're split. Like, okay. Okay. So this was also something that you were talking about a while back. The parallel processing of GPUs. Problem is I don't know the difference, so like I don't have enough information to have an opinion about it. We are processing every forward-backward pass of the transformer. The block size, as I explained, is the maximum context length to make those predictions. So let's say batch size 4, block size 8, and then here's how we get batch for any arbitrary split. If the split is a training split, then we're going to look at train data, otherwise at val data. That gets us the data array. And then when I generate random positions to grab a chunk out of, I actually generate batch size number of random offsets. So because this is 4,
ix is going to be four numbers that are randomly generated between 0 and len of data minus block size. So it's just random offsets into the training set. And then x's, as I explained, are...
We're getting different random blocks of 8 and batch of 4 so that it's not overfit on the order of the whole thing, but we still want some order in our context, right? In his context, it was the evolution of GPT. I think I would be curious about what he has to say.
the first block size characters.
Oh, by the way, it's 24th of June, and Google Podcast was put to rest yesterday. Like, I opened it yesterday, and it was like, today's the last day that it will be available. Please go to YouTube Music. I was like, fine. So, yeah.
Starting at I, the y's are the offset by 1 of that, so just add +1. And then we're going to get those chunks for every one of integers I in ix, and use a torch.stack to take all those one-dimensional tensors, as we saw here, and we're going to stack them up as rows. And so they all become a row in a 4x8 tensor. So here's what I'm printing then. When I sample a batch xb and yb, the inputs to the transformer now are the...
Oh, really? Huh. I'm aware of the rabbit R1 whole situation that's happening right now, but less so about perplexity. I mean, I don't know. I'm not gonna defend anyone, but I'm just saying sometimes products have some tricks that may look like they're more complex than they actually are. And when those are found out, oh yeah, exactly, the overpromise. And maybe something that was assumed automatic is actually not. It's 1,000 people from India. And then now people have become more like, self-driving 6 months away. What about going to Mars in the next decade? That has been said. Apple Intelligence killed the rabbit. I don't know who killed the rabbit, but someone killed the rabbit. It's basically, yeah. Why Apple Intelligence? I can't say. But yeah, I think people are more speculative. Is that the word? Like, just open to bad, like, to critique bad products now. Like, before, you couldn't, I don't know, like 50 years ago, you couldn't, unless it was a review in a magazine, you couldn't be aware of it. And now more people are aware of it. That's why. And there are more bogus products, right? So everything has the potential to be a scam, obviously. Just what is the scam? I guess the word scam, it would be like, anyway. Rabbit kill rabbit. Yeah, Kofizola did the expose. I think I watched that video yesterday because I watched the most recent video where he's saying, they say it's automated, it's not. And then I looked at the one that was, I think, from a year ago. You had hope? I think, I don't know. The rabbit and then the other one, the clip-on one, both are the same idea. Because the rabbit can also see. It has a camera. Well, it was too soon, like too early. They jumped too high. Yeah. Yep.
The input X is the 4x8 tensor, 4 rows of 8 columns, and each one of these is a chunk of the training set. And then the targets here are in the associated array Y, and they will come in to the transformer all the way at the end.
I mean, there was an actual thing you can hold it with your hands. So how can you not call that a product? There is a toy. Yeah, basically just hype, yeah. And a lot of money raised. How do they, I don't know, like what do they do to raise so much money? I wish I knew. The startup market is just crazy.
The end to create the loss function. So they will give us the correct answer for every single position inside X. And then these are the 4 independent rows. So spelled out as we did before, this 4x8 array contains a total of 32 examples, and they're completely independent as far as the transformer is concerned. So
they are independent because they're coming randomly. It's like an app. Yeah, 100%. Yeah, I actually agree with you. Could have been just an app. Yeah, product offer no advantage beside being an exclusive platform for generic software. Yeah, and even the thing where you can see your history. It's a web app. You're right. You know, they say this meeting could have been an email. This product could have been an app.
When the input is 24, the target is 43, or rather 43 here in the Y array. When the input is 24, 43, the target is 58. When the input is 24, 43, 58, the target is 5, etc. Or like when it is a 52, 58, 1, the target is 58. Right, so you can sort of see this spelled out. These are the 32 independent examples packed in to a single batch of the input X, and then the desired targets are in Y. And so now this integer tensor of X is going to feed into the transformer, and that transformer is going to simultaneously process all these examples and then look up the correct integers to predict in every one of these positions in the tensor Y.
Cool. I could defend the selling of an app with a locked-in hardware. Like, I have by their reasoning, software isn't good enough. That's actually true. Yeah. Like, right now, I think Fitbits, like, no one thinks one should not, like, it is an excessive thing. Like, it's something you buy for fun, but, like, having it is useful. Probably phone can count your steps, can tell your heart rate based on whatever, I don't know. There are stuff like that, but having some sort of watch that also tracks your health stuff, like there's no one saying that's a scam, right? AI will be, oh yeah, huh? Oh, sorry, I read as AI, sorry. Devices will be glasses in 2 years as claimed for GotSource. Like in science fiction movies where everyone can see what is on your phone from the back. Like an Android phone and an Apple phone are basically the same hardware. True. Yeah. Yeah, I get it. Like, yeah, reductive, but yeah. Made a quick Google spreadsheet. Whoa. Oh, hey. That's cool. Sent to Discord. Why not? No phone? Huh? Of what? Oh, I get it. Okay, yes, got it. Can we? Yes, we can. We did it. There it is. Oh, okay. No phones. Yeah. Intel. Wow. Already solved the issue of people seeing what use with wearables. Just turned out that pointing a laser in the wearer's eyeballs was less popular than they predicted. What? I mean, I remember the Snapchat glasses. I don't know what happened to these. Okay. So we have engram thingy. 1, 2, 3, 4, 5, and then another. And then I can't, sorry, the screenshot is a bit small, but question. Hold up, can I read it here? I don't think I can read it here as well. Is it a bit small? Nope. No, it's actually fine. Hold up. Is the image, why are those two images different? No, they're not. Wait, why does it look better on the screen? That's weird. Do you do that? Oh, there it is. I am so sorry. I do not know why I opened such a weird one. Okay, now we can see it. Do you do first scenario or second scenario? First, second. He made an Instagram? No, wait. Smart glasses look more. Wait, where? To put display in your eyeball. Hold up, why do I not know about this Intel thing? First scenario, still grouping data. They're very, nice. That's interesting. Okay, so we have gray, green, and purple. And then, would they be in their own thing? I think that sort of this chunking that Andre is doing sort of answers this, doesn't it?
Okay, so now that we
Hold up. Why aren't you leaving the screen? Let me. So if I go back,
it's going to simultaneously.
We have like 1, 2, 3, just like your 1, 2, 3, right? 1, 2, 3, 1, 2, 3, and it will see like scenario 1 the way I see it, because even this, when input is, output is. The engram spreadsheet is an instant engram. Is anyone keeping track on which of us is? That's funny. Who is best at keeping me off topic? Someone needs to keep score. Is that another way of keeping me distracted? I was like, just like a few minutes ago, I was like, oh, actually it was not a few minutes ago, it was half an hour ago. I was like, wait, it's been 1 hour and I've only watched 10 minutes. I think this is not a good strategy. It's funneling the N to the parallel GPU. Yes. But
process all
I
these
go
decisions into a
forward.
transformer.
Yeah.
Let's start.
Like this is one, let's call it sentence. This is one sentence, and this is how, like, it's grouped together. Yeah. The way that we are teaching our model, I'm thinking it's scenario 1. Right now we're at 20 minutes, but I've been streaming for an hour and 40 minutes, so yeah. So can the chat agree with me that scenario 1 is the correct, what's happening right now, instead of scenario 2 where it's a bit jumbled? Parallel doesn't interest me as much as a GPU poor person. If I had a farm of them, I could keep busy. Huh? What does that mean? No, you don't have to shut up. I mean, whatever. As in, if you don't feel like talking, you can not talk, but no one's telling you to shut up. I'd care more. Yeah, you're right. We don't have enough resources to think how we would use them. Okay. Yeah. I think I'm not anywhere near, but making models run or on less resources is something that is interesting. 1,000 GPUs I'd care about parallel. One day. You never know. Now, chat, please answer me. Stop going off topic. Well, not really. We're still on topic. Scenario 1, right? Can we see the screen? Scenario 1, right? Yeah. I mean, if we have 3 things, 3 rows. It is seen in its own context. Like even this n-gram thing is basically, yeah. Just realized I never bothered about the shuffling technique. Maybe this is important. Huh? What do you... Okay, 1 million per month electric bill. Yeah, but if you make 1 million per minute, then you're good. Yes, so even here, each one sees its own window. There is no shuffling between friends. Yeah. So I hope that answers your between these are not even neighbors. It's just showing us what it looks like based on the window. Yeah, I hope that sort of answers your question, Ed. Also, if you use solar panels, you should be okay. But the upfront cost is too much. Sure, we shall blame coffee. What are we blaming coffee about? Get the guillotine. How is time going? Time is going like 8 more minutes left. The causal. Someone wrote, making means you can train one. In parallel. Oh, causal masking. I read making. Yeah. That's cool though. Oh yeah, the 10-minute thing. Nah. We won't blame coffee. It's 22 minutes. That's pretty okay. Also, n-gram models. We're making an n-gram model. I can't blame coffee because without coffee, I'd probably have to do a lot more Googling. Yeah. They share same resources. Cool.
Start basically feeding this into neural networks. Now, we're going to start off with the simplest possible neural network, which in the case of language modeling, in my opinion, is the bigram language model. And we've covered the bigram language model in my Make More series in a lot of depth.
Hold up. We're saying bigram as in using 2. You know what? I'll let him explain. Because I thought our window was 8.
And so here I'm going to...
Characters. These are characters.
To sort of go faster, and let's just implement the PyTorch module directly that implements the bigram language model. So I'm importing the PyTorch NN module for reproducibility. And then here I'm constructing a bigram language model, which is a subclass of NN module. And then I'm calling it, and I'm passing in the inputs and the targets. And I'm just printing. Now, when the inputs and targets come here, you see that I'm just taking the index, the inputs x here, which I renamed to IDX, and I'm just passing them into this token embedding table. So what's going on here is that here in the constructor, we are creating a token embedding table, and it is of size vocab size by vocab size. And we're using nn.embedding, which is a very thin wrapper around basically a tensor of shape vocab size by vocab size. And what's happening here is that when we pass IDX here, every single integer in our input is going to refer to this embedding table and is going to pluck out a row of that embedding table, corresponding to its index. So 24 here will go into the embedding table and we'll pluck out the 24th row. And then 43 will go here and pluck out the 43rd row, etc.
Block out.
And then PyTorch is going to arrange all of this into a batch by time by channel tensor. In this case, batch is 4, time is 8, and C, which is the channels, is vocab size, or 65. And so we're just going to pluck out all those rows, arrange them in a B by T by C, and now we're going to interpret this as the logits, which are basically the scores for the next character in a sequence. And so what's happening here is we are predicting what comes next based on just the individual identity of a single token. And you can do that because...
Oh yeah. Good question. So, I mean, even this is something different, right? Because of the ruined schedule, I was like thinking, should be a something different Tuesday, or since we don't have Sunday and Wednesday to work with, we just use what we do the best with what we have. I'm thinking sort of like continue this as far as I can, because this gives me a better understanding for the assignment. I don't think I can finish this in like 2 streams. I don't know why though. Months in general are going too fast. Oh yeah, that's true. I think it's an age thing. The older you get, the faster things move. Yeah. Like I'm thinking, I'm saying that for myself. So maybe we can have tomorrow also be the continuation of today, and see where we can go from there, because then Wednesday comes around. Today's a Monday. Yep. How's your Monday going? Is it like a Garfield level Monday, or is it just a Monday? Also, why is no one telling me I'm blocking Andre? Sorry about that. I feel bad. Where was I? Logits. Right. Is every logit this logit thing? Or is that just for this case? I am curious. Okay. Yep. Basically time's up. And this block is, I technically can, yeah, if it's 10 minutes. No, that's too much. It's 10 minutes. Okay. I thought it's less. Oh, I can come back to this part here tomorrow. Yeah, let's be efficient. Cool. Does Garfield hate Sundays if Garfield was Muslim? Good question. I mean, like, Turkey has so many cats and they like every day. So our cats don't hate days? I don't know. But like, depending on, yeah, okay, no. Right now, like a good percentage of the workforce starts work on a Sunday. So yeah, maybe. But even like a few years back, schools would be open 6 days a week, not 5. Now it's 5. So like my most, for me, when I was a student, the day that I was scared of was Saturday. Because like you'd have 1 day of weekend, which is just not enough. But now kids these days have it easy. They have 2-day weekends. I think they have longer classes now by like, I don't know. Anyway, that is not interesting at all. Yeah. Thank you for tolerating me today. I was a bit all over the place. Yeah. Sometimes I get I jail myself in my expectations. Like I feel like I'm in jail of my own making. and just doing something that's different helps me get out of my brain jail. So today felt like I got out of my brain jail. Thank you for all the distractions. Yeah. I mean that. And I mean, I'm not saying I have any issues. I'm just saying my expectations for myself, for what I need to learn, is too high. Thank you, JSS. I think we had we had 5 different chatters today. I think, maybe. I'm just trying to do some sort of a thank you to Coffee, JSS, Ed, Sahil. I think that was all today, yeah. I should try to make myself do the tutorial offline. Yeah, sure, why not? Why not? You should try if you want. I can send you the link to encourage you further. So thank you for today. Appreciate. Thank you for. Yeah. Yeah, why not? Take a look. It is very interesting, and like he is spelling it out, trying to be not confusing. Okay. Have a lovely rest of your Monday. And inshallah, I'll do my best to be here tomorrow at a better time so that I can give more of my time to this tutorial. Yeah, this forward function made me happy because I was supposed to write a forward function somewhere else, but yeah. Okay. I was going to start with make more ones. Maybe. I don't know what make more is, but sure, why not? Oh yeah, he has the make more series. Why did I think it was a maker series? But yeah, why not? You know what? Maybe you start with this one, which is a bit high level, and then you go back. Because for me, I don't know why, but that trick works for me. Start with something hard, and then when you go back, you understand the thing that was harder. But maybe we are on different levels, so. Okie dokie. Thank you again for being here and for talking with me and for being lovely people in the chat to each other, because that's also nice. I am going to end today's stream. Inshallah, if you'd like to stop by next time, why not? If you don't feel like it, cool. And yeah, that's all. So I'm gonna start the countdown. If there's anything else, let me know. Otherwise, see you around somewhere. Okay. Ending the stream in 5, 4, 3, 2, and 1.